Prep Station Physics, welcome back. Okay, we actually started something on the calculation of wave speed. So let's quickly complete that, and then we can look into other aspects of waves. Okay, remember we still have other things to discuss like the properties of waves and all of that. Now let's go through this again. Let's look at it again. I started by defining speed from the normal definition as what? Distance over time. But then I said, because we are dealing with wave, you are not going to use distance, okay? Then we're going to use what? Wavelength, because wavelength is the distance covered by one cycle of wave. And if that is the case, okay, then I'm going to change lowercase t to what? Uppercase t. Why did I do that? Because the time taken to cover one cycle of wave is called period. So you cannot use the lowercase here, but the uppercase, which signifies period. Now, that is to say this formula is V is equal to lambda over big T. Take note of this formula. Let me call this equation 1. Now, there is another formula used in this calculation. How did they arrive at that formula? That is what I want to explain now. Now, period, by definition, is equal to time divided by number of oscillation. Recall, frequency from the formula I gave you is equal to number of oscillation divided by time. Now, look at these two equations and compare them. What did you observe? What did you observe? Look at it very well. Now, if you look at these two equations, you will agree with me that one is the inverse of the other one. Okay, one is a flip of the other one. Look at it. Period is T over N, but frequency is N over T. So which means by implication, okay, I can also write that T period is equal to what? 1 over F. Look at it again. Now, where am I getting this from? From here. If T, big T is small t over N and F is N over T, it means big T is equals to 1 over F. So the reciprocal of the frequency for a traveling wave is the same thing as the period. Now, let's factor this back into this formula, equation 1. Let's factor it back into that. So V is equal to lambda over 1. Now, times 1 over T. Now, follow me from here. Now, this can also be written as lambda over 1 times, what is 1 over T? Look at this expression. If T is equal to 1 over F, then F is equal to 1 over T. Do you agree with me? Look at it again. If T is equal to 1 over F, then F is equal to 1 over T. So if that is the case, where I have 1 over T, I can simply switch it to what? To F. Now, finish this off. Then from what you have here, we can simply say that V is equal to what? F times lambda, which is the most simplest way of calculating waves. So this is the formula that is being used here. So come back again to this question. In this example, the frequency is 5. The wavelength is 2. Fine. So what is the speed? Let's do it together. F, if frequency is 5, and then wavelength lambda is 10. Wavelength is 10 meter. Frequency is 5 hertz, written in short form Hz. So what is the speed? V is equal to F lambda, isn't it? Look at the formula here. So just substitute. If you substitute this into the formula, then you can say V is equal to, in the place of F, write 5 times. In the place of lambda, write, what now? Write 10, okay? Frequency 5, wavelength 2. Okay, sorry, the wavelength is 2. I was using 5 here. The wavelength is 2. So change this to 2 meter. So change this to 2 meter. Now, 5 times 2, what will that be? 5 times 2, of course, the answer will be 10. Therefore, the wave speed is 10 meters per second. So that is how they got this 10 meters per second. I want to believe that was clear enough, right? Okay, so let's move forward. So in a precise form, this is the formula. V is equal to F times lambda. Okay, and then you can always switch. You can always make the unknown the subject of the formula. For example, if you are looking for frequency, all you need to do, divide velocity by wavelength. And if you are looking for wavelength, divide velocity by frequency. Okay, now there is still another way of doing that. This is called the formula triangle, although this is for the elementary level. Okay, but I just have to bring this up because I really want you to get the whole definition about waves and how to go through it. Okay, I'm trying to make it as simple as ABC so that everyone can understand. So this is called the formula triangle, which also represents the formula for wave equation. It's very simple. Look at the triangle. At the top you have V. V stands for speed. Then on my left hand side where you have this finger, you have what now? F, which is frequency. On my right hand side you have lambda. Okay, now below the triangle you have X, which represents multiplication. Okay, and then by the side of the triangle you have the division sign. What does this really represent? Now all you need to do is to use your finger to cover whichever parameter or variable you are looking for. For example, if I want to calculate frequency, all I need to do is to use my finger and cover the frequency. So if you cover frequency, this is frequency now. It means to find frequency, I will have to take V, which is at the top, and then divide it by what? Lambda, which is below. Look at it now, divided by. So V divided by lambda. That is the first one. What if I want to calculate lambda? The same thing. Just switch this finger, use it to cover lambda. So this is lambda now, wavelength. If I want to calculate wavelength, just cover it. Then you'll be left with what? V at the top divided by what? Frequency below. And then lastly, if you want to calculate velocity. Now velocity is what? Now velocity is at the top and then the other two parameters, they are down. What is the relationship between them? Is times multiplication. So if I'm looking for velocity, I will simply say F times lambda. Okay, I want to believe that was simple enough for you to grab. So that is it. Formula triangles help you to rearrange formula. The triangle for the wave equation is shown below. Whatever quantity you are trying to find, cover it up and it will leave you with the calculation required. I've just illustrated that now. So if you are trying to find frequency, what will you do? Use your finger to cover frequency, okay? Use your finger to cover frequency. Now you will cover F up because I'm looking for F, right? Now if you do that, you are left with what? You are left with the sum of what? F will be equal to V over lambda. I have already explained that, how to use the formula triangle. Although this is for elementary level, but then we can also use it at the college level, okay? And it makes the explanation very easy. You can use it to calculate anything that has to do with wave velocity, frequency, and wavelength. Okay, let's move forward. Which wave below is longitudinal? Okay, which wave below is longitudinal? Okay, I just want to test you a little on what we have discussed so far. We started from definition of wave, what is wave, how to describe wave. Everything I've been saying since is all about description of wave. Okay, so we are going to touch other aspects of wave in other series, but everything about this series has been description and definition of waves. So if actually you have gotten something from what I've been saying since, let's see if you can answer this question. Which wave below is a longitudinal wave? Now you have option A, B, C, D. Now we have ultraviolet wave, water, light wave, sound wave. Which wave below is a longitudinal wave? Now, if you were actually paying attention you will know the answer to this question, because while explaining types of wave, I actually mentioned the answer to this question. So what would the answer be? The answer is sound wave. Okay, the answer is sound wave, because sound wave is longitudinal wave because it travels parallel. Okay, it travels parallel to the direction of propagation. I want to believe you can hear me as I'm talking right now. That's an example of longitudinal waves, and of course it's sound wave. As I'm talking right now, okay, I'm producing pulse, and the pulse is vibrating the air medium around me, and that vibration will cause the air to, a section will be compression and a section will be expansion, but we don't call it expansion, we call it refaction. So we have a section of refaction and then a section of compression. So continuous refaction and compression will create what? Disturbance in the air. And that is how the sound wave from me is being carried out. And that is why you can hear me right now. So sound wave is an example of longitudinal wave. I know you'll be looking at water. Water is supposed to be longitudinal wave. Yes, of course, depending on the instance you are looking at. But if you are looking at like wave on water, when water is actually moving on series of waves, you can't call that longitudinal. It will be transverse. When water is forming ripples, okay, if you disturb water and ripples is formed, that cannot be longitudinal wave. It's transverse wave. So the correct answer for this question is sound wave. Let's look at another one. What are the units of frequency? What are the units of frequency? What are the units of frequency? Now, which of these represents the units, okay, of frequency? We have meters, we have hertz meters, we have hertz per meters, and then we have hertz. What is the answer? Now, you can always go back to the definition for frequency, and what is it? Number of oscillation divided by time. Okay, number of oscillation has no units, but time, unit of time is second. So you can simply say number of oscillation per second is the unit for frequency. But just to make it a little bit precise, we have to name this after the scientists that really work on this, and that is Frank Hertz. Okay, so the unit of frequency is Hertz, spelled H-E-R-T-Z. In short form, you have it as Hz. Okay, and then another question before we round up this section, that is the answer. You can see it's being checked there. The answer is Hertz. Then another question is, a wave has a wavelength of 6 meters and a frequency of 5 hertz. What is the speed of the wave? This is very simple, right? And I know you can handle this. You can handle this. How? Just go through the formula. And what is the formula? In case you have forgotten, let me write it out again. The formula is what? V is equal to lambda over big T, or V is equal to F times lambda. So any of this formula can give you the answer, but how will you know which one to use? Then you have to go through the question and write out the given parameter. That is how to solve problem in physics. You see, there's a formula we normally use in solving problem in physics, which is called a grass method. Okay, maybe in another series I will explain what the grass method is really all about. Okay, whenever you have question in science, not just in physics, mathematics, physics, chemistry, always apply the grass method. G stands for given. Okay, write out what has been given in the question. A stands for required. Okay, find out what you are required to do and make that required the unknown. Then A stands for analyze. Figure out which formula can handle that problem, okay? Because in a particular topic, you may have up to 5, 20, 10 formulas, but then figure out which formula will solve the problem easily. And then A stands for what? Solve. How do you solve? Make the unknown the subject of the formula, substitute the given parameters into the formula, and then play with the numbers using your calculator, or just play with it using your mathematical knowledge. Then the last S there is statement, a concluding statement. Okay, whenever you solve a problem, give a concluding statement. to show yes, this is what I was required to do, and I have arrived at the final answer. So having said that, let's go through it gradually. Given a wave has a wavelength, so I'm going to start with that. 6 is for wavelength. And what is the symbol for wavelength? Is lambda. So I'm going to say lambda is equal to 6 meter, right? Hope you got that. Lambda is 6 meter and a frequency of 5 hertz. Good. Now, frequency, what is the notation or symbol for frequency? F. So I'm going to write F is equal to what now? 5 hertz, Hz, short form of writing hertz. What is the speed of the wave? So the symbol for speed is what? V. Now, you don't know the value, okay? And that is what you are required to do. So what will you do? Just give it a question mark, okay? So question mark, this is what I'm looking for. I am looking for the speed. Fine and good. Now, look at the two formulas here. V is equal to lambda over big T, or V is equal to F lambda. Which of these formula can solve this problem? Now, how do you decide? Decide by looking at the parameters given. Now, in the parameter, I have lambda, I have frequency. So I'm not going to touch the first formula. Why? Because it has period, and I was not given period. Now, the second formula has frequency and wavelength. So it will be wise to use this one, okay? Though we can still find the solution with this. Yes, it's possible. I can convert the frequency to period and then use that to solve. But why wasting your time if you have a formula that can give you the answer without stress? So we are going to use this formula. V is equal to F lambda, okay? I want to believe you actually got that, how I decide on which formula to use, okay? So V will be equal to, what is F? Put the value. Now at this stage, you are substituting the values into the formula. So F is 6 meter, good, multiplied by the wavelength is 5 hertz, good, all right? Now, therefore, that is the concluding statement now. Therefore, the speed, therefore, V, which represents speed, will be equal to what? Now, 6 times 5 is 30, right? Now, in my conclusion, I have to write it in full, including the unit. So speed will be equal to 30. Now, ensure to put the unit, because if you don't put the unit, it doesn't make any meaning, okay? Because 30 can represent anything. 30 can be currency, money. 30 can be distance. 30 can be frequency. So you have to indicate the unit. So for this, 6 times 5 is 30. So that is going to be 30 meters per second as the answer. So looking at these options right now, what do you think is the answer? Is it A? Is it B? Is it C? Is it D? I think the answer should be D. All right, let's look at that. Yes, you can see it checked. So the answer is D. So I want to believe you got all of that. So with this, we have come to the end of this series. Till when I meet you again for the next series. Thank you.